Hello, my name is León from the University of Stuttgart. As the coordinator of the project, it's a pleasure for me to present the main outcomes of our research activities. I hope you see the next slide now. The overall project objective of Trust was to contribute to the question on how to achieve the Sustainable Development Goal number 6. As in many prosperous regions of the world, fast-growing urban centers, population, and economies are facing water shortage. And this is particularly valid for Lima, Peru. This is the capital of Peru, and also its surrounding region, because different factors related to economy, population, and water demand pose major challenges to water governance and SDG 6 attainment. In Trust, several different disciplines of researchers from natural engineering and social sciences worked together to develop management concepts integrating these three domains of water resources, water use, and water management. And first, a solid information base was key to perform analysis and to develop innovative concepts. Especially in areas where data availability is limited, existing information has to be complemented by further data collection. For example, analysis of remote sensing, setting up of new monitoring stations, or by performing surveys and interviews with local stakeholders. In the following, I will present some highlights of our performed analysis and concepts for each of these three domains. The first domain refers to water resources. Our study area, the Lurin River, is characterized by strong seasonality of river discharge. And additionally, monitoring of water resources is incomplete. To assess available water resources, we combine different approaches. Setting up new monitoring stations for rainfall and discharge, hydrological modeling, remote sensing, and in addition, we developed a water safety plan tool for risk assessment of the water resources at catchment level. For the sake of brevity, I would like to present only some aspects in the next slides. This is the Lurin River catchment, which stretches over 1,600 kilometers in Lima and South Lima, and rainfall occurs mainly in the upper part of the catchment above 1,500 meters above sea level. At the start of our project, there was only limited information on how much water is generated in the upper part, how much is infiltrating in the lower part, and how much water is draining to the Pacific Ocean. In order to make a detailed assessment of the hydrology, we had to set up new stream gauges to complement the data availability. For example, this figure illustrates our results of the cumulated discharge of the two stream gauges in 2019. From the difference of the two stream gauges, we could infer to the infiltrated water volume, which hints at the possible sustainable groundwater usage, and also to the water which is draining into the Pacific Ocean. With this example, I only want to demonstrate how strategic location of new monitoring stations can help to get important information on available water resources that are important for decision making regarding water management planning. On the topic of water quality, we have developed a prototype of a decision support system that has been tested in 2 different case studies. This tool is based on the water safety plan approach, focusing on water-related risks. Users of this interactive tool are able to analyze the potential risks of water contamination in the catchment area. At the marketplace, you can find a video and a webinar with further information. The water users, their objectives and policies. So in this domain of water use, we have developed a new methodology to design sustainable policy mixes. This policy interaction model approach analyzes synergies and trade-offs between the different objectives of water users on the level of interactions between alternative policy instruments and measures. We tested this approach within participatory processes involving local stakeholders in the Lurin catchment for strategic planning of water use. This figure shows the developed policy interaction metrics, analyzing interdependency between 14 objectives and 47 policies of the different water users in the upper Lurin catchment and the lower catchment. We have prepared a webinar if you're interested in more details on this approach. With this policy interaction model, we did two things. First, we looked at individual policy mixes. For example, here the status quo policy mix, to understand where inconsistencies are and how strong they are. For the Lurin catchment, for example, it showed that the main conflict refers to groundwater abstraction, referring to water quantity conflicts and to insufficient treatment of domestic wastewater, dealing with water quality conflicts. Second, the model allowed us to identify alternative, consistent, and synergetic policy mixes, which are effective to join the objectives of the different water users and contribute to attain SDG 6. Within the domain of water management, the third column, we developed integrated solutions for drinking water supply and wastewater treatment, considering the local boundary conditions, as well as the preferences and concerns of relevant actors. Capacity building for operators and awareness raising activities for water users were conducted in order to support the development of technical concepts. For the Lurin River case study, we considered both rural highland communities and the urban structures in the lowland with high population density. For the lower Lurin Valley, for example, we have identified that the greatest potential for water reuse is there. Treated wastewater from municipal wastewater treatment plants can potentially be used in agriculture, in industry, or for artificial groundwater recharge. Whereby in the upper area of the catchment, we focused on safe drinking water supply and treatment of wastewater in rural communities. Main tasks range from participatory assessment of technical concepts, empowerment of the communal water organization, and implementation of pilot plants. In the village of San Andrés de Tupicocha, in the upper part of the catchment, safe water drinking supply is an imminent problem. With the design of a pilot plant, we aimed to examine whether fine sediments which contaminate drinking water in the rainy season can be separated. Next to the drinking water plant, we focused on the construction of a pilot plant for safe wastewater disposal. This plant cleans the wastewater in several stages, whereby a trickling filter is the main component of the treatment. We have also last Friday we had an interesting side event on this topic, and we have also more details in the our marketplace booth. Coming to the end of my presentation, based on our work, we draw the following 4 conclusions. First, field work remains necessary for quantifying and modeling hydrological systems in a sufficient manner. The use of remote sensing data and derived products to increase data availability still requires further research. Second, policy interaction modeling and its results are a useful starting point for integrated water planning processes, contributing to reduce goal conflicts, to meet the demand of all water users, and to attain SDG 6. Third, training and capacity building of local water service providers, as well as awareness raising for the local water users, are key factors for successful implementation and long-term operation of drinking water and wastewater facilities. For this purpose, we recommend to set up a pilot plant as training module before implementing a large-scale plant. Fourth, through implementation of participatory formats during the planning process, it is possible to learn about conceptions, priorities, and practices, and allows gaining a social-technical perspective regarding innovative drinking water and wastewater management concepts. You will find a comprehensive document with all the results and more recommendations of the project in our marketplace booth. And additionally, we are also preparing a transfer document for other cities and regions with water shortage. All of these activities and achieved results would not have been possible without the effort of the participating partners from universities, institutes, research companies, and consultings. I would like to take this opportunity to thank the whole trust team for the 3 years of trustful cooperation. Last but not least, it's important to mention also our partners in Peru. There has been a continuous cooperation with organizations ranging from companies, public authorities, research institutes, international organizations, and also the municipalities, for example, from San Andrés to Picocha. And with this slide, I want to thank a lot for your attention.